we are done with the discussion of the sequential order and the conditional order, which has single selection, double selection, and multiple selection. So for now, we will be starting with the iterative order. So iterative order, iterative. So iterative order, another, you can also call it as iteration, or commonly called as looping. Now, one particular characteristic of an iteration is that it has a repetitive process, of course. Now, iteration or looping allows you to simplify those problems which has repetitive process. So to explain this clearly, let me have an example. Okay, wait. Okay, suppose you were asked to write an algorithm. So write an algorithm that will input and print 20 names. So if you're going to write this, are you going to write an algorithm for this? So step 1, start. And then step 2, you're going to read a name. So read name 1, for example. And then step 3, read name 1. Oh, no, print name 1. Then step 4, read name 2. And then step 5, print name 2, and so on. So the process continues until you reach 20 names, and that will be a tedious job. Okay, that's why we utilize the iterative order for that. So definitely that is not the wise thing to do. Okay, so let's revise the algorithm. Now let's analyze first the problem. So you are asked to input and print 20 names. Okay, so to perform this, you should have a counter to keep track of the process if it has reached the limit or it has reached 20 names already. So for that is one characteristic of looping or iterative order. There should be a variable that will keep track of the process. So that's what you call the counter. So let me first discuss what is a counter. So this is one basic characteristic of an iterative process. So an iterative process must have a counter. So your counter should be initialized. What will be its initial value? Your counter must be tested if it has reached the limit. And then your counter should be incremented. Or you have to increment or increase your counter to continue the process. So for step 2, we have to initialize the counter. So step 2 will be initializing the counter. So initialize counter. You may initialize it to 0 or 1. So for now, we will be using 1. So I'll be using CTR for the counter. So initialize CTR or counter to 1. Okay? And then the next step is we can read now the name. So read name. And then, according to the problem, after reading the name, we have to print the name. Now, after reading and printing the name, we should test the counter. So we should test. So we have initialized the counter, we have tested the counter. We will test the counter rather. So step 5 will be testing. So let's have here step 5. So if CTR is less than 20, we have to increment the counter by 1. So to do that, we have counter is equal to counter plus 1. And then, to continue the process, we have to go back, the process of reading and printing names, we have to go back to step 3. So just issue the command or the step, go back to step 3. And then, if the condition will be satisfied, or if the counter has reached 20 names already, it will then stop. So the last step will be step number 6, end. So let us test if our algorithm is correct. So step 1, start. Step 2, initialize the counter. So the present value of our counter will be equal to 1. Okay, so this is the initial value. And then suppose this is the screen of your monitor. Okay, so read name. So for example, you input a name, Badet, and then the name that you have inputted will be printed on step 4. So print name. So this will print Badet. And then we will test the counter. So if counter is less than 20, so the present value of our counter is 1. So we're going to test. Is 1 less than 20? Yes. So we will increment the counter until it reaches 20. So counter is equal to, the present value of counter is 1. So 1 plus 1 this will be equal to 2. So the present value of our counter now is 2. That's why it is called a counter. It keeps track on the process. And then after that, go back to step 3. Okay. Again, we will read name, for example, Alex. And then what you have entered will be printed in step 4 again. So that will be Alex. And again, we will what? We will test the counter. So the present value of our counter is 2. So is 2 less than 20? Yes. So the counter will be incremented again. Since the present value of the counter is 2, that will be 2 plus 1 is equal to 3. And then go back to step 3. So read again the name, for example, Bruno, and then print the name, Bruno. Okay, so the present value of our counter is 3. Test again. Is 3 less than 20? Yes. And then the process goes on until it reaches 20. So let us draw the corresponding flowchart for this algorithm. So again, we will draw the terminal symbol. And label it with start. So let me introduce a new symbol, which is the initialization block. Initialization block is represented by this shape. This is where you initialize or declare your variables. So for example, you have to initialize counter to 1. So doing this is draw the symbol and then label it with counter is equal to 1. And then the next step is step number 3, read name. So reading the name, you have to use the parallelogram or the data symbol or the input and output symbol and then label it with read name. So the next step or step number 4 is print name. Again, for data and for input and output, we use parallelogram shape. So just write print name. Now, the next step is to test the counter. So testing the counter, we will use the decision symbol. Since I don't have any space here at the bottom, I will be using the on-page connector. So the condition is if counter is less than 20, so this will be the label for our decision symbol. If CTR is less than 20, if the condition is true, what will happen? So the counter will be implemented. So counter is equal to counter plus 1. That is a formula. So we will be using the process symbol. Counter is equal to counter plus 1. And then the next step is go back to step 3. So going back to step 3, we can use an on-page connector which will be labeled as letter B. So step 3 is read name. So we will go here. And then what if the condition is satisfied already? So we have inputted 20 names. So the condition will be false. And that will mark as an end of the process. So this is the flowchart for our algorithm. So let us test if our algorithm is correct. So let me have here a sample window. So our counter is initialized to 1. And then read name. So for example, we read the name B, then print name. So it will print the name B. And then if counter is less than 20, the present value of our counter is 1. So we will test. Is 1 less than 20? Yes. So the counter will be incremented. So counter is equal to counter plus 1. The present value is 1. 1 plus 1 will be equal to 2. And then we will go back to step number 3, which is reading the name again. So using the connector B, the on-page connector B, so we will read another name. For example, name C. And then what has been inputted will be printed. So C will be printed on the screen. And then we will test again the counter. So the counter is 2. So is 2 less than 20? Yes. So the counter will be incremented again by 1 until it reaches 20 names. So this is the equivalent flowchart for this algorithm. So in an iterative order, we have the so-called body of the loop. So the body of the loop consists of those statements that are repetitive. So here in our example, steps 3 to 5 are the statements inside the body of the loop. Now, we have two kinds of iterative order. What I am discussing now is the count controlled loop. Count controlled loop. Count controlled because it has a limit. So for example, print 20 names, print numbers from 1 to 5. So it has set a limit. So that's why it's called count controlled. And of course, it has a counter. So I'll be discussing another type after I discuss 2 more problems for this type of looping. Now, let us have another example for count controlled loop. So write an algorithm that prints numbers from 1 to 5. Okay. So the algorithm asks for a solution or an algorithm that will print automatically the numbers from 1 to 5. So what are the repetitive process? Printing those numbers. So step 1 will be start. Step 1, start. And then step 2. Again, since we will be dealing with count controlled loops, we need to initialize our counter. So initialize the counter. Initialize CTR. Again, I'll be using CTR all throughout the discussion. CTR is equal to 1. And then the next step will be, so we can print the counter. So print counter. And then right after that, we're going to test for the value of counter. Step number 4. So if CTR is less than 5, so what will happen? So the counter will be incremented. CTR is equal to CTR plus 1. And then we will go back to step 3. We will go back to step 3 if the condition is not yet, if the condition is not yet satisfied, or if the limit hasn't been reached. And then after that, step 6, or no, step 5, end. Okay. So this is the algorithm for printing numbers from 1 to 5. So let us test this algorithm if this is correct. So let me have here a screen. So for example, we have here your display screen, for example. So start. Initialized counter is equal to 1. Now, step 3 instructs you to print the counter. The present value of the counter is 1. So 1 will be printed on the screen. And then step number 4, test for the value of 1. For the value of counter. The present value of our counter is 1. Is 1 less than 5? Yes. So the next thing that you're going to do is to increment the counter. The present value of counter is 1. So 1 plus 1 is equal to 2. And then go back to step 3. Step 3 instructs you to print the counter. So the present value of counter is 2. That's why 2 will be printed on the screen. And then again, test the counter. Is 2 less than 5? Yes. So the counter will be incremented again by 1. So 2 plus 1 is equal to 3. And then go back to step 3. Print the counter which has the value or the present value of 3. And then test the counter. If 3 is less than 5, yes. So again, increment the counter by 1. So the counter will be equal to 4. And then go back again to step 3. Print the counter which is 4. And then test for the counter. Is 4 less than 5? Yes. So the counter will be incremented again by 1. So the present value of our counter now is 5. So is 5. Oh no, go back to step 3. Print counter. So we have to print the present value which is 5. Now, is 5 less than 5? So it's false. So the shifting of logic will be going to step 5. End. So the algorithm answers the program. So numbers from 1 to 5 will be printed on the screen. Now let's try another problem. Write an algorithm that asks the user to input 5 numbers and print their sum using the iterative order. So to analyze, again, the user will input 5 numbers, and then using the iterative order, there should be a variable that will hold the partial value of the sum. Okay? So we will have another variable for this, which is the accumulator. Okay. So let's start with the algorithm first. So step 1, start. And then step 2, of course, we have to initialize the counter. Initialize CTR is is equal to 1. And then we have another variable, as what I have said a while ago, that we will be using an accumulator. Okay. So let me discuss. So the variable for our accumulator is sum, which is always initialized with a value of 0. So sum will be equal to 0 as its initial value. So to discuss, so what is an accumulator? Okay. Accumulator. So its function is to, so the sum is the accumulator in this problem. So its function is to accumulate the values. Okay. So to accumulate. So every process, the sum will be incremented depending, or will be summed up partially depending on the number that has been inputted. So that is the function of the accumulator in an algorithm, in a flowchart, or in a program. It keeps track the value, the partial value of this, of every process. Now let's continue. Step number 3 is reading the number. So read num. So I'll be using the variable num for the numbers that will be inputted. So read num, and then after that, step 4, we can now add partially the number. So using the accumulator sum is equal to sum plus num. Okay. You will add to the accumulator the number that has been inputted previously. And then after that, step number 5 is to test the value of the counter. So if CTR is less than 5, because we are adding 5 numbers, so we have to increment the counter. CTR is equal to CTR plus 1. And then we will go back to step number 3. Step number 3, if the counter hasn't reached the value of 5. Now, if the counter has reached the value of 5, of course, the loop will stop, and then we're ready to print the sum. So step 6 is print sum. And then, of course, step 7 marks the end of the algorithm. So this is the algorithm for this problem, which is to input 5 numbers and then print their sum. So let us draw the counterpart, or the equivalent flowchart for this. Okay, again, your flowchart must begin with the terminal symbol labeled by start, and then the next thing, or step number 2, is to initialize, using the initialization block, the counter and the accumulator. So CTR is equal to, or counter is equal to 1, while sum, which is the accumulator, is equal to 0. So the accumulator always starts with 0, depending on the problem that is given. And then step 3 is read num. So using the data symbol, or the input-output symbol, so read num. And then after reading the number, you are now ready to compute or accumulate the sum. Then sum is equal to sum plus num. So the next step is, which is step number 5, is to test whether the counter has reached its limit or has reached the value of 5. So decision symbol. If CTR is less than 5, so if yes, if it's less than 5, then we will increment the counter. It's equal to counter plus 1. And then we will go back again to step 3, which is read the number. Okay. Now, if the counter reached, so I'll be using an on-page connector, since I don't have any space at the bottom of the paper. So let me continue in this part. So B, I have used A for the on-page connector, so the next letter would be letter B. And then what if the counter has reached the value of 5? So if the loop is finished, or the process is finished accumulating the value and entering 5 numbers, now we will go to step 6, which is printing the sum, and then end. So let's have a test data for this. So let us see if this flowchart and this algorithm adds 5 numbers. Okay, so the present value of our counter is 1. Our accumulator is 0. Okay, so read num. So for example, I have here, okay, wait. So I have here, for example, a screen or a monitor. Okay, we will run our flowchart. So the counter is 1, the sum is 0. Read num. For example, I have inputted number 5. So that will be added to our sum. So the initial value of our sum is 0. And then the number that was inputted or that was entered is 5. So 0 plus 5 is equal to 5. So the present value of our sum now is 5. And then we will test the counter, which has the value of 1. Is 1 less than 5? Yes. So counter is equal to counter plus 1. So that would be 1 plus 1, 2. So the present value of our counter now is 2. And then we will go to reading a number again. So read num, for example, 7. Okay. So the present value of sum is 5. So 5 plus num. So 5 plus 7. So 7 was the previously entered number. So 5 plus 7 is equal to 12. Okay. So the present value of our counter is 2. Okay. So let us test. Is 2 less than 5? Yes. So we will increment again the counter. So 2 is the present value plus 1. So the value of our counter now is 3, and then we will go back to reading a number. So read num, for example, 3. So again, we will accumulate. So sum is equal to sum plus num, or the present value of sum is 12. So plus 3, that will be 15. And then test again the counter. So the counter now is 3. Is 3 less than 5? Yes. So increment the counter. We will add 1 to the present value of the counter. So this will be, the present value will become 4. And then again, let's go back to reading a number. Okay. So read num. So I input 1. So again, accumulate. Sum is equal to sum plus num. The present value of sum is 15. So 15 plus 1. 1 is the number that was read previously. So 15 plus 1 is equal to 16. And then let us test the counter, which has the value of 4. Is 4 less than 5? Yes. So counter is equal to counter plus 1. So the present value of our counter now is 5. Okay. So we will go back to reading again a number. So read num. For example, I input 2. So 2 we will accumulate again. So 16 is the present value of sum. So 16 plus num, which is 2. This will be equal to 18. And then we will test the counter. So the present value of the counter is 5. Is 5 less than 5? So definitely not. No. So 5. So we will leave the process of accumulating or the looping process. Then we will go to the on-page connector, which states that we have to print the sum. So the accumulated sum is after the last process, the last value or the recent value of sum is 18. Okay? So this flowchart definitely answers the problem. Okay? So 5 plus 7 is 12, plus 3, 15, plus 1 is 16, plus 2, 18. So this is the flowchart for this problem. So I hope you learned a lot from this lecture. Maraming salamat sa pakikinig. So stay safe lagi. Sending my virtual hugs. So, ciao. Mwah.